Hello everyone, this is Ethan from the Huan lab at the University of British Columbia. We are excited to announce the newest version of our peak checking software for mass spectrometry, pyEVA. So, what is pyEVA? pyEVA is software we've developed to aid in evaluation of the quality of chromatographic peak shapes. But typically this is a long and time-consuming manual task using state-of-the-art deep learning technology, specifically a convoluted neural network. pyEVA is capable of automatically processing and accurately determining which peaks are true positives and which ones are noise. We aim to streamline this process using a user-friendly program running in Python. In this video, we will cover how to download pyEVA, the installation process, and how you can use it. First, pyEVA is available for download on our GitHub page, where it comes with a detailed user manual with the contents of this video. To set up pyEVA, first go to the zip file, download it, and unzip it, as shown here. Once you've unzipped it, you still need a few other software pieces to finally install it. Among them are Anaconda, PyCharm, and RStudio. Once these are all downloaded and installed, open the Anaconda navigator that comes with Anaconda and boot up PyCharm, professional or community versions. Then, to open the project, we will go to File, Open, and navigate to the folder where you have downloaded pyEVA. Open up the terminal by clicking Alt plus F12 or at the bottom left of the screen here. Type in conda and create file environment.yml. Press enter. This process is lengthy, however, so we've omitted it here. Once the environment is finished being set up, you will notice that pyEVA will appear beside your console command line. Next, to set up the interpreter, we will navigate back to the menu, open up Settings, also opened by Ctrl-Alt-S, navigate to the project and the interpreter, add interpreter, local interpreter, and under Conda environment, simply select the Use Existing Environment and pyEVA. Then press OK and OK. This concludes setting up the interpreter. We will now install some other packages necessary for pyEVA. In RStudio, we will type in the following. Once you've typed this in, simply press Ctrl-Shift-Enter to run the entire R script. And the packages, once they've been installed, will appear in the bottom right here. Now that the program is set up to run, we will show you how to use pyEVA to run your data. In the folder where you have installed pyEVA, navigate to the readme.md file, and in it we include a link for the demo data we will be using in this video. Download it, unzip it, and take the contents of it, copy them into the input folder as shown here, then simply go back to the PyCharm project, type in python main.py. Choose a peak smoothing level for it. We suggest choosing the same smoothing level being used in your data processing workflow. Then we wait. This process may take longer or shorter depending on how much metabolic features you have in your CSV and its associated xcms or xml files. Under our testing conditions, using a regular desktop computer, pyEVA processed about 30 features per second. Now that the process is complete, we can see the output files, prediction outcome, and final table in the output folder. The final table is more interesting for us, as it contains most of the outcomes in prediction outcome and more, such as the feature ID, the MZ, the RT, intensity of the feature, and whether pyEVA predicts it to be a true or a false feature in the sample. Correspondingly, if we navigate to classifier and EIC plots, we can see the EIC plots for each feature. Next, if another dataset is desired to be run, we simply take all the contents of EIC plots and the output folder, move them into a separate folder for wherever you want to store it, and replace the contents of the input folder, the demo data, with your data. This should be a CSV file and its associated MZ XML or xcms files. Once this is done, simply navigate back to pyEVA in PyCharm and type in python main.py once more and press enter. This concludes our video on how to download and use pyEVA. Thank you for watching, and we hope it helps you out.